this example deals with lasers, and the problem states as such. Shown is a 3-level diagram that are involved in a lasing action. Not a lazy action, lasing action. The E2 state is going to be the metastable level, and E0 is going to be the ground level. And this happens to be the energy between them. So we have E0, E1. The difference between them is going to be 0.165 electron volts. The difference between E0 and E2 is going to be 0.289 electron volts. Once again, this is going to be the metastable level. E0 is going to be the ground level. And that means that E1 is not a very long-lasting state. So E2 is going to be the longest lasting state. So the first question reads as such. What two levels are involved when the external source of energy initially causes the electron to jump to the higher energy state or higher energy level? So the ground state, so E0, this is the ground state. And E2, this is the metastable state. It's not as stable as the ground state, but it's more stable than E1. So a question reads once again, what two levels are involved when an external source of energy initially causes the electron to jump to a higher energy state? So as the population moves from E0 to E1, it's then going to move up to E2 because E2 is going to be the more stable state. Any population E1 is not going to last long, and so the two states that are involved in this are going to be E0 and E2. All right. Now part B asks, between what two levels does the population inversion occur? So in this case, we're looking at the population inversion, and what happens is, once again, you move population from E0 to E1, and then the population is going to eventually move up to E2, such that there becomes more of a population in E2 than there's going to be in E1, because this is not a stable state. E2 is a more stable state, and so the population inversion is going to occur between states E1 and E2. Now part C reads, between what two levels does the lasing action occur? What two levels does the lasing action occur? So if we're looking at the lasing action, I already wrote an A. If we're looking at the lasing action, it's going to occur between E1 and E2 because that's where the population inversion occurs at. Now D reads, what energy must an external source provide to start the lasing action? So in order to move, so D, so how much potential has to be supplied to this? Well, we have to get the population to move from E0 up to E2. That has to happen. And the energy between that is 0.289 electron volts. Now E asks, what wavelength of laser light will be produced? So for E, we want to come up with the wavelength of light. And for that, we have to look at a change in energy is going to be equal to E2 minus E1. Now the reason we're choosing E1 as opposed to E0 is because the lasing action is going to occur between E1 and E2. And that is equal to, so the difference between that is going to be 0.289 minus the 0.165, which gets us to 0.124 electron volts. So if we have 0.124 electron volts, we convert that into joules. So 1 electron volt is equal to 1.6 times 10 to the minus 19th of a volt or joule. This is going to equal to 1.984 times 10 to the minus 20 joule. All right, once again, we can find our lambda. Our lambda is going to be equal to HC divided by E, which is 6.626 times 10 to the minus 34 joule second times our speed of light, which is 3 times 10 to the 8th meters per second, divided by our energy, which is 1.984 times 10 to the minus 20th joule. Joules cancel, seconds cancel in units of meters. This becomes equal to 1 times 10. Oops, I should put a few more digits in. It doesn't really matter. They all become 0. This becomes 1.00 times 10 to the minus 5th of a meter, which is in the infrared regime. So this is the wavelength, but the portion of the electromagnetic spectrum that this laser is going to produce is going to be in the infrared regime. So this laser could actually be used for molecular vibration spectroscopy because molecular vibrations occur in the infrared regime. In order to excite molecular vibrations, you have to bombard that sample with infrared radiation. Of course, the infrared radiation has to be resonant with that particular mode or motion. If you have any questions on problems referring to lasers or anything else in this chapter, feel free and please let me know.